Hello, this is a recorded version of a talk that I gave at the Bx workshop recently, the International Workshop on Bidirectional Transformations, based on this paper, Confidentiality in the Process of Model-Driven Software Development, by Mike Johnson and myself. And if you're interested, you should be able to find the paper either via my webpage or via Google. Obviously, if you have any trouble, let me know. This is my first venture into writing about security, so I bring naive enthusiasm, and for expertise you need my co-author. I got a laugh at the Bx workshop by phrasing that by saying that I was spending my sabbatical this year writing papers about things I know nothing about. Of course, that's a rather caricatured version of the truth, which is to say, when you have a sabbatical, it's lovely to take the opportunity to read literature that you weren't very familiar with and take first steps into new areas. Another thing I'm trying to do on my sabbatical is to get much more comfortable with producing pictures to use in my slides, so I hope you like that one. So the idea of this is that the way we normally think about the process of software development is that, regardless of whether developers trust users, developers are supposed to trust one another. If you're cooperating with another developer, you're supposed to be comfortable sharing information with them and working together, even if they come from different organisations. People in blue tops should be able to work with people in orange tops, and everything in the garden should be rosy. Now, in practice, if you've done development that involves people from different teams or different organisations, you've probably experienced something that looks a bit more like this. Our organisations, even if they're well motivated to work together, nevertheless find that there are some things they're not happy to share. They have particular assets or particular facts that they feel obliged to keep hidden behind walls, and so the developers end up not in a completely trusting situation, and this can have radical effects on the effective weather of the software development. But is this a good thing or a bad thing or an inevitable thing? This is what we need to go on to discuss before we go too much further. There's not very much in the literature on this, so when I started to get into this area, I went off to people in my school who do know a lot about security, and I said, hey, I'm looking for literature on confidentiality in the process of software development, and I'm not finding very much. Please give me some pointers. And I was expecting them to say, oh yes, you need this and this and this and this and this. And what they actually said was, ooh, that's a bit interesting. You might want to look at this. So there is some, and we discussed what we found in the paper, but there is much less than I was expecting to find. What seems to be the case is there's huge amounts of work on producing software that can keep things confidential from users, and very much less on producing software while keeping things confidential from developers. So why would this be important? Why wouldn't we just say, well, trusting developers is good? In fact, when you go and look at the literature, you find that there's a lot of literature on how to improve trust between developers, how to, for example, set up your social structures so that people will feel able to trust one another with information. One of the things we would like to say is that it's easier to trust people with information when you feel confident that you know what information you should and should not be trusting them with. So in fact, being explicit about what information should be shared, in the way we'll suggest, is not a way to reduce trust between developers, but actually a way to increase it. People can be either under or over cautious in sharing information, and everybody benefits from being deliberate about that and knowing what their intentions are. Many exploits, including many of the famous ones you'll have come across, depend on knowing details of a system in order to know how to exploit it, and those details can come from a variety of different sources. So they can come from reverse engineering, and for example, if you've read about Barnaby Jack's jackpotting exploits involving persuading automatic teller machines to give out money without subtracting it from any user's account, you have encountered developing knowledge of the details of a system via reverse engineering. The Greek Vodafone exploits involving a very complicated setup of wiretapping based on Ericsson switch software and some murky political involvement combined with a great deal of technical understanding of how to do the wiretapping and understanding details of the variant of the software that was installed in Vodafone, and many aspects of that are really still murky, but there was clearly a lot of insider knowledge there going on, at least insider knowledge coming from operators. Industrial robot exploits, the reference we have there is to a paper discussing how many of the people involved in the software of industrial robots lack a very clear understanding of the potential exploitation and the potential risks that come from that exploitation. But to my mind, one of the most interesting aspects there is the observation that if you actually look at the software that is made publicly available or very widely available, because we're talking about software that has to be available to any user of a commercially available robot, if you look at the software there that's made widely available, it's clear that the developers of the software had, at least intuitively, some idea that there were confidentiality issues going on, because they made some attempt to obfuscate some aspects of the software, like keys, for example, that could be used to do such exploits. Now, they did not obfuscate it in a very reliable way, but at least this is telling us that some developers have become aware of some issues here, but they were not working within a framework or an architecture that enabled them to completely effectively use their understanding of the potential risks to mitigate those risks. What literature there is out there comes under the heading of insider threat and mostly focuses on integrity. But one of the things to observe is that even just confidentiality can be important, because an insider doesn't need to be able to actually change something to cause problems. In particular, exploits that depend on confidential information can then be exploited from outside sometimes. Now, you can hear I'm running into the fact that I'm new to this literature and not incredibly familiar with it, so let me move swiftly on. We're used to the idea that security by obscurity is no security. Evidently, people are using security by obscurity because they feel the need for some kind of security and they don't have mechanisms to give them better ways to provide that security. Something needs to be discussed here. Why do we want to think about this in the context of model-driven development? Well, obviously, partly I want to think about it in the context of model-driven development because that's the kind of development that I'm most familiar with. But I certainly want to argue that this is a good setting in which to discuss having limits on trust, because the thing that we already deal in is separation of concerns, and many of the concepts that we use in this field are centrally concerned with those kinds of issues. So many of you who have heard me talk recently have heard me declare that this picture now has to be in every talk I give at least once. So this is the future vision of model-driven development. So the idea is that we have different groups of stakeholders, and each group of stakeholders is working with a model that records all and only the information that they need to know. So we might say up here we have two different groups of users of the software, each working with a model that records the aspect of the software behavior that they care about. And down here we have another group of stakeholders. You can tell that they're mathematicians by the Greek letters, so perhaps they are safety experts or something of that ilk. And then we have our coloured wires, which are our bidirectional transformations. And their job is to maintain consistency between all of these models. So to do that, they have to possibly modify the models in order to bring them into consistency. If the red group makes a change to their model, it may be that there is a knock-on change that's then required to the blue group's model. And ultimately, the bidirectional transformations have to bring all of these models that are developed by the stakeholders into consistency with one another and into consistency with the eventual deployed software, which will actually be pushed out and used there. Now, one of the things that makes it difficult to do development is that you quite often end up with hidden dependencies that are not made explicit between the models. And if you weren't convinced by my earlier arguments that we might want to be concerned about trust between developers, and we might want to limit that trust, here's a completely different argument, which is to say what you don't know you can't depend on. And so if we say actually the blue developers really can't see the red developers' models, then they certainly cannot have any hidden dependencies on it. The only dependencies on it will be those which are explicitly maintained by the bidirectional transformations, and that will potentially be a thing which makes it easier to maintain our software correctly. When we're in a situation where we're surprised that there is even a threat to worry about, it's helpful to be explicit about what kind of threat we're talking about. And to do that, the standard mechanism is to develop a threat model. And in order to develop a threat model, you have to do three things. You have to identify the assumptions that you're making about the setting within which you're working. You have to say what, inside that setting, are the potential harms that you're trying to guard against, and you probably also want to rank them. And having done that, you want to say, well, what are we going to assume about the knowledge and capabilities of the adversary against whom we're trying to guard? Once you have a threat model, you're in a much better position to try to institute policies or mechanisms for guarding against those threats and to make rigorous arguments about the success of those policies or mechanisms. So let's have a go at doing that. The setting we're going to work in is cooperating organisations, by which we mean organisations which have some reason to cooperate, and nevertheless which have interests which are not perfectly aligned. This arises in a number of different kinds of settings. We might be talking about parts of one organisation which are in some way distributed, and so literature on this turns up under the headings of distributed software engineering, or on a larger scale, global software engineering. We might be talking about different organisations, organisations which in some settings cooperate and in other settings compete, and which therefore want to be quite mindful about what information they do and do not share between one another. We might be talking about highly asymmetric situations. For example, in the gig economy, we might want our major corporation to be employing contractors to develop pieces of software for them, but they might not want to have an ongoing trust relationship with the contractor. They might want to be giving away just enough information to enable the contractor to do their job and no more. And so you find things in the literature that talk about things like doing a global replacement on strings, for example, to avoid having strings tell the contractor things about what the software they're developing it to is going to be doing. But of course sometimes that's not enough. Sometimes the very structure of the software may give away information. So we're talking about sharing some but not all of the information that one organisation has with another organisation. Cooperation can often be framed using models, and for us in the MDD community, that's a very natural and a very useful thing to do. Now remember, everything's a model. In this setting, what matters about a model is it's a thing with a boundary. Some things are in a model and other things are not in a model. So a model here might be anything from a specification of an API through to an entire subsystem. It's a thing which is owned by an organisation, and it's going to, in the future of this talk, it's going to be things which are shared between organisations, made explicit. Next, let's go on to think about potential harms. And first of all, we're going to think about why things might be confidential. Why might we not want to share information with another organisation? So this comes under several headings. The broadest is the first one, the protection of intellectual property or trade secrets. And here we have several reasons why we might want to protect such a thing. The biggest is that sharing that information might enable some kind of attack. And we might here be talking about a technical attack that would prevent the use of the software or leak data from it or whatever. Or we might be talking about a business attack. We might be talking about the kind of attack that would enable another organisation to attack our business, for example, by stealing a trade secret and bringing a product to market before ours. We might be talking about patents or a similar situation where we're obliged to protect something in order to be able to argue that it's ours. We might be talking about a situation where we have licensed some information from another organisation on the condition that we adequately protect it. We have issues of protection of personal data, and that might be data about users of software, or it might be data about our own developers, it might be information about anybody. We might be talking about reputational risk. We might be talking about a situation where we don't want it known that there are certain quality problems in some artifact that's used inside our organisation, or we might, even going the other way, not want it known by our competitors that we have particularly high quality of some artifact within our organisation, that that's the secret to our business success. We might want to be making sure that we don't have a conflict of interest or the appearance of a conflict of interest between parts of an organisation. So it's in certain cases we might want, for example, to be able to guard against accusations of insider trading by making sure that one part of an organisation doesn't have knowledge of something that it shouldn't have. The other thing to be aware of is that even if organisations A and B, which are cooperating, trust one another implicitly, they may still want to control somehow the information flow between them because of the fact that their developers are not necessarily going to stay where they are forever. The developers from A or B, which trust one another, might perhaps move to C in future, and C might be the sworn enemy of A or B or both, and at that point you might want to have some kind of limit on what your developer actually knows about your business. What might be confidential? Well, basically anything that is used within software development might be confidential. You can make up your own scenarios here. Which things do I particularly want to draw out here? Well, let's give an example where the meta model might be confidential, for example, since that's perhaps slightly less obvious than other issues, and it's going to be important later. So suppose, for example, that I, in organisation A, am developing a product that uses a component supplied by organisation B, and so A and B are collaborating to make sure that the component works with the product. Now, I am modelling that product that uses the organisation B component in a domain-specific modelling language, whose meta model, if made completely public, would reveal the fact that I'm also working on another product in which, instead of using organisation B's component, I'm going to use organisation C's component. Now, that might well be something that I don't want organisation B to know at this point, and that might limit the extent to which I want organisation B to see my entire meta model, for example. I think I'll leave you to make up your own scenarios for why the rest of that stuff might be confidential. It's not too hard. And let's think about the kinds of setup that we've got here. So here is a picture of our initial non-automated setup, in which we have no automated bidirectional transformations going on. We just have human collaboration between the developers. So we've got organisation A, and organisation A's information is modelled in model M, and organisation B, whose information is modelled in model N. And we are going to model the cooperation between the organisations by saying that they have to bring models M and N into consistency from time to time. It might be because M incorporates an API and N has to use that API, for example. Now, without any automation, what has to happen is that A and B have to sit down and talk to one another, and they're probably going to sit down and they're going to, in some fairly unregulated way, share information about their models, and any kind of controls that they have over there are going to be entirely human and informal. So in the BX workshop setting, the obvious next step is to say, well, can we automate the consistency restoration and thereby gain some kind of control over what information goes to whom? So before we make that explicit in a picture, let's move on a step and look at the capabilities that we may want or forbid an adversary to have. So supposing that A is trying to limit the knowledge that B will have of their model M, what capabilities does B have to retain? I think we can definitely say that we want B to have full knowledge of model N. After all, that's the model that belongs to B. So B will certainly have read access to N. It's probably also unreasonable to forbid B to have either of the next two capabilities. We expect B to be able to change model N, their own model, and we expect them to be able to cause consistency restoration to be done at will. We expect them to be able to invoke the bidirectional transformation. But as soon as they've got both of those two capabilities, they have the capability to change n, not in order to actually change their requirements or their software development, but in order to probe m. And that's going to be something which is going to raise some quite interesting technical issues. Things get slightly more arguable when we talk about whether we want the parties to have knowledge of the consistency restoration process, including the definition of consistency. So there we're going to have to say, well, how is consistency defined, and to what extent can we do that without giving away information about the models that are being maintained in consistency? And we are probably going to try to want to quite tightly control the change of the consistency restoration process and the definition of consistency itself. That's likely to be quite sensitive. So let's make that explicit using a bidirectional transformation, and here's a picture of that. So here we have a bidirectional transformation taking over the job of maintaining consistency between models m and n. Now normally a bidirectional transformation is written by hand by, in this case, a software developer I've described as the bookser, and the bidirectional transformation will normally be written in terms of the meta-model of model m and the meta-model of model n. And so the bidirectional transformation writer will write the bidirectional transformation in terms of these meta-models. The bidirectional transformation then acts on the current state of these models in order to restore consistency. The idea here is now that B will have access to the meta-model and the model on their own side, and will be able to invoke the bidirectional transformation, but will not have any direct access to the model M or its meta-model. However, in this naive setting, the bidirectional transformation writer still has to be fully trusted with access to both M and N. Now let's think for a moment about how we can start to limit that. One of the reviewers pointed out that we might want to consider a situation in which the bidirectional transformation was learned rather than explicitly written by a bidirectional transformation writer. That's an interesting thing to think about, and maybe there's some interesting scope for research there. But even if you're doing some kind of learning or some kind of bidirectional transformation by example, you've still got to have a source of examples, some kind of specification of what the bidirectional transformation has to do, and that probably already gives away quite a lot of information. Now you might be able to win there, because you might be able to say we can win by telling the bidirectional transformation writer what hypothetically they would have to do if the models were such and such, without actually giving them access to what the models really are right now. And there might be some scope for doing that. But it's an advance, but there's probably still going to be some considerable amount of human involvement at that point. We've also got issues involving stuff like where is the bidirectional transformation actually going to run. It's probably going to run on a machine which will have M and N on that same machine, and then we've got to be very careful about access to that machine that now has all of that information in the same place. So we've helped a bit here, but we have not by any means solved the entire problem. In the experience of Mike, who has done a lot more work than I have in this area, and in particular has over many years worked with clients who wanted to cooperate but were concerned about confidentiality issues there, using a common view takes us a big step further on than that more general approach of using a bidirectional transformation. So what we're showing here is the idea that organisations A and B have agreed on a common view that they both agree does not contain information about which either of them has confidentiality concerns. So they're quite happy to share this information. And then, on each side, their own developers write an asymmetric lens that maintains the consistency between the full model and the common view of that model. So A's developers develop this asymmetric lens, and B's developers develop this asymmetric lens, and the view captures explicitly the information that they're happy to share. Now this gives them confidence that they're not sharing information that they don't want to share, and equally importantly, it allows them to talk openly in terms of all the information that's in the view. So this is a good step forwards which has been discovered and rediscovered by people working in this field, and that we think deserves to be made more explicit in this way. There are still a lot of topics that need more work, though. So one interesting thing is to say we know that some bidirectional transformations can be expressed in that way as a pair of asymmetric lenses, a co-span of asymmetric lenses onto a common view, but we also know that not all bidirectional transformations can be expressed in that way. So way back in a paper in Bx'12, I invented the term simply matching for the bidirectional transformations that can be expressed in that way, and it turns out to be closely related to a categorical notion called difunctionality. And I investigated the bidirectional transformations that have that property, and for a while I thought that it was reasonable to say that all interesting bidirectional transformations have that property, and that turns out not to be true. The Bx'18 examples repository now contains a fairly convincing example that does not have that property. Nevertheless, perhaps particularly in database-oriented areas, Mike's experience is that a co-span of lenses very often suffices, so it would be nice to understand in more detail why that's the case, and his paper with Bob Roseborough in the same workshop has quite a lot more to say about that. It would be very interesting to have formal support for this and some interesting guarantees about information flow. Zinovy-Diskin and colleagues have done some work on trajectory pairs, which might perhaps be exploitable in this area. I'm very much interested in taking bidirectional transformations beyond the case of two models, and it would be interesting to see what that has to say, what new concerns that brings up at this point, if any. Another thing I've been thinking about is the kind of notion of bidirectional transformations all the way down. What kind of mileage is there in the use of this kind of technique inside one organisation, using common view models essentially as a kind of API more broadly? And of course we've already touched on the fact that although our focus is on confidentiality here, that isn't because only confidentiality is important. It's just because we wanted a place to start, and we certainly want to broaden our focus in order to talk about integrity. In fact, there's an interesting tension between integrity and confidentiality in some ways. One way to look at this is to say one of the interesting pieces of related work that we did find is a paper by Foster Pearson Stanovich about updatable security views. Now, their focus is rather different from ours. They use asymmetric lenses, and one of the things they do there is to have a get function that gives you a view onto a source, some of which is confidential and some of which requires its integrity protected. And then they will forbid the application of the put function if the put function would change the source in a way which is not to be allowed. But one of the issues there is that that gives away some information about the integrity relations between something that might have changed in the view and the existence of some data in the source that you might not otherwise have known about. In other words, it might give away some information that might be confidential. So it would be interesting to explore that a bit more. But positively, it might very well be useful to combine these ideas and think about actually using an updatable security view in place of the plain asymmetric lens that we had in our previous picture. Anyway, this was only a first step, but I hope that's been interesting, and if you were in the workshop, I would ask you whether you had any questions or comments, but as it is, I'll just have to say, feel free to email me if you have any questions or comments, and do include Mike too, because he's much more likely to be able to answer your questions.